In this video, we are going to see realization of one flip-flop to another flip-flop. So we know that flip-flop is a memory element which can store one bit of data, right? And then so it is possible to convert one flip-flop to another flip-flop, and then we have to use some additional logic gate, right? And now we are going to see how to realize one flip-flop to another flip-flop, right? So for this we have to follow some steps. So we are going to see what are they. So first step is we have to identify available and required flip-flop, and second step is we have to write down the excitation table for the available flip-flop, right? So for the available flip-flop we have to write the excitation table, and then third one is we have to write the characteristics table for required flip-flop, right? So we have to write the characteristics table for the required flip-flop. And next one is, so we have to develop the characteristic table for the realization. And next one is we have to find the input expression for the available flip-flop in terms of required flip-flop inputs, right? And the last step is what we have to draw the logic diagram for our realization, right? So now we are going to see one example. So here we are going to convert SR flip-flop into D flip-flop, right? So SR flip-flop into D flip-flop, right? So first step is what we have to identify what is the available flip-flop and what is the required flip-flop, right? So we are going to convert SR into D flip-flop. So SR flip-flop is what available flip-flop, and D flip-flop is what required flip-flop, right? And the next one is what second step. So second step, so we have to write the excitation table for the available flip-flop, right? So excitation table for the available flip-flop, right? So excitation table is nothing but the table consists of present state and then next state. So for these two combinations, what are the inputs, right? So this is what excitation table. So excitation table, so here we have to list out the present state, next state, and for this combination, right? So two variables we are having, so four possible combinations. What are they? 0 0 0 1 1 0 1 1, right? So for this four combinations, what will be the input? So this is called was excitation table, right? So here the available flip-flop is what? SR flip-flop. So the excitation table is what? Qn plus 1, right? So this is what present state and this is what next state, and for this available flip-flop these are the inputs, right? So we have to write down the combinations. So 0 0 0 1 1 0 1 1, right? So for this combination, so we have to decide the inputs, right? So the shortcut for this excitation table is what? 0 1 0 x, right? So we have to remember this, right? 0 1 0 x, and or comes the reverse of s, right? So x 0 1 0, right? So this is what excitation table for the available flip-flop. And next one is what? Third step. So third step is we have to write a characteristic table for the required flip-flop, right? So characteristic table for the required flip-flop, right? So characteristics table is nothing but, so we have to list out all the inputs and then present state. So for this combinations, what will be the next state, right? So the table consists of inputs and the present state. For this combinations, what will be the next state? So this table is called as what? Characteristics table. So we are going to write the characteristics table for the required flip-flop. So our required flip-flop is what? D flip-flop, right? So we have to list out all the input and the present state combination. So 0 0 0 1 1 0 and 1 1, right? So these are the four combinations, right? And for this four combinations, so we have to write down the next state, right? So for the D flip-flop, so whatever the present state, So the output will be what? Whatever we are giving in the D terminal, right? So the D flip-flop, the next state will be what? So whatever inputs we are giving in the D terminal, right? So the next state will be what? 0, 0, 1, 1, right? So now we have written the characteristics table for our required flip-flop. And next, fourth step. So fourth step is what? So we have to develop the characteristics table for our realization, right? So for our realization, so this is the table. So first we have to write down our D flip-flop characteristics table. So 0 0 0 1 1 0 1 1. So for this combination, so these are the output, right? So this is what required flip-flop. So the required flip-flop characteristic table, right? So characteristics table. And this is what available flip-flop. So the available flip-flop, so we are going to write down the inputs for this present state and the next state, right? So for this present state and this next state, right? So this is what required flip-flop. So for the required flip-flop combinations, we are going to develop the inputs, right? So by referring our excitation table, right? So by referring our excitation table, excitation table, we are going to write down, right? So 0 0, so 0 0, S is what? 0, and R is what? X. So we are going to write down here, right? And next one is what? 1 0, so 1 0, so S and R will be what? 0 and 1, so 0 and 1. And then here what is 0 1? So 0 1, right? So here we are having 0 1. So for this 0 1 combination, so the inputs is what? So the inputs are what? 1 0, so 1 0. And the last one is what? 1 1. So for 1 1, the inputs are what? X and 0. Right? So this is the characteristics table for our realization. So we can, right? And the next one is what? Fifth step. So fifth step, we have to find the input expression for the available flip-flop in terms of required flip-flop inputs, right? So this is our characteristics table of our realization. So for this, we have to find out the expression for this S and R, right? So for this, we are going to draw the K-map. So the K-map consists of two input, right? So the D and QN, right? So D and QN. So this is what next state. So we should not consider this. So D and QN. So D and QN, right? So this is what 0 1 and this is what 0 1, right? So this is for what? Yes, right? For yes, we are going to find out the expression. So for 0 0, so 0 0, our S is what? 0, right? And for 0 1, our S is what? 0, right? And then 1 0, so 1 0, our S is what? 1, right? And 1 1, our S is what? X, right? So now we have to group. So we are grouping these two. So now the expression for S is what? So here QN is changing and here we are having D, right? So S is D, right? And second thing, so we have to find out the expression for R, right? So for R, we are going to draw the K-map. So similarly, we are having input D and the present state. So for these two combinations, we are getting the R, right? So for first one is what? So this is what 0 and 1. So this is what 0 and 1, right? For 0 0, R is X, and for 0 1, R is 1. For 1 0, our R is what? 0, and for 1 1, our R is what? 0, right? So now we are grouping these two, right? So now the expression for R is what? So here Qn is changing, and here we are having what? D complement, right? So now we have found out the input expression for S and R. So S is D and R is what? D complement. And then so the last step, sixth step. So here we have to draw the logic diagram for our realization, right? So the expression is what? S equal to D and R equal to D complement. So for this expression we have to draw the logic diagram, right? So first draw the available flip-flop. So our available flip-flop is what? SR flip-flop. So SR flip-flop, and then here we are having Qn and Qn complement, and here we are having clock, right? So this is the symbol, right? Logic symbol of what? SR flip-flop. So now we are going to connect the input S and R, right? So input for S is what? D, right? So we can connect D to this S, right? And R is what? Complement of D. So this is D. So we have to give the complement of D to the R. So we have to connect the inverter here, and we have to give to the R terminal, right? So this is the logic diagram for our realization SR to D flip-flop, right? So hope you understand. Thank you.